Hey guys, so this is Unit Mathematical Models. Our objective today is to go over terminology and go over graphing functions. So, a function. A function is a relationship where an input has exactly one output. So, take for example this funky machine, right? So you're inputting something and it's going to be your x, and it goes through this process called a function, and your output is your y, okay? So you're putting in something into the function and you're getting out your output, okay? Input, output. Now, the function for this example is search for friend's Instagram account by their username, okay? So the input would be the username. Your output would be your friend's account, right? So when I want to find one of my friends, I go in, they have to give me their username, I go in, I do the search, and then I put in their username, and I'm going to only get that account, right? Now, an example of not being a function is if I were to search for my friend's Instagram by searching for their first name. Because if I go in and I put Jessica, I'm going to get a lot of Jessicas, right? I'm not going to find my friend's account. So if I just input the first name, my output is a lot of accounts. So that's not giving me only one output. That's giving me many outputs, okay? So a function is where you put in one input and you should get out one output, not many outputs. If you're getting out multiple outputs for one input, it's not a function. Now, what I want you to do is go ahead and take a moment, pause the video, and think of a function that when you put in one thing, you only get out one thing. You can't put in one thing and get out multiple things. Okay? So take a moment, think of a function that you put in an input and you get out one output. Now, all of the inputs of a function are called the first set, and we more commonly refer to this as the domain. So the inputs are the x, you put it into some function, some machine, and all of those inputs are called the first set. And when we're talking about graphs and everything, we talk about the domain. We don't call it the first set, but your book does. Okay? So, there's an input. All of the inputs for a function are called the first set, and we also call it a domain. All right? Now, all of the outputs of a function is called the second set, and we also call the second set the range. I know this is a lot of terminology, and I apologize for that, but you need to be familiar with the different words because they are used interchangeably in your text. Okay? So, again, inputs of a function, all of them are called the first set, and we also call the first set the domain. All of the outputs combined is a second set, and it is called the range. Okay, so if they say second set, you need to think of the range. If they say first set, you need to think of the domain. Let's look at this picture. It's The Simpsons. It's pretty cool. So what you have is the carnival mirror. That is the function. It has an input and it has an output. In this case, the input is Homer, and the output is a funny image of Homer, right? So the reason why I did this function is because your output in the text is also referred to as image. So I wanted you to have a point of reference to think about image as the output. Okay? So in your book, it'll say, what is the image of x equals 1? So my input would be 1. The image would be the output once it goes through the function. Okay? For example, we're given the function y equals x squared. And the problem would be find the image of x equals 1 and x equals negative 2. So all it's asking for is the output when x equals 1. So let's do this really quickly. So I have y equals, and then it says x equals 1. So I put in 1 into the function, and the output is going to be 1, because 1 squared is 1. So the image of x equals 1 is 1. Same thing with x equals 2. So we have y equals 2 squared, and that gives us an image of 4. Or sorry, negative 2 squared. Don't forget to include that inside the parentheses. If you put it on the outside of the parentheses, you get negative 4, and you don't want that. So this negative 2 right here, the negative, needs to go inside the parentheses when you substitute. Because if it's on the outside, you'll get a negative 4. Okay? Now, so that's the image. Going back to the domain. The domain is the whole first set of numbers, right? And the first set of numbers is all of the inputs that I can put into a function. So I'm looking at this function y equals x squared. There are no values of x that I can't put in. So I can put in all real numbers. So the domain is going to be all real numbers. And if you remember from last year, we designate that as the double-sided R. Okay? Now, the range. You have to think about what can you get out. So if I take any number and I square it, I can't get out a negative number. What is the lowest value I can get out? Well, that would be 0, right? Because if I put in 0, I get out 0. But I can't get any negative numbers. So my range is going to be y when y is greater than or equal to 0. Okay? So that's how we write our range. You say y when y equals, or when y is greater than or equal to 0. Okay? Again, that's because that's all of the values of your output that it could be. Now, a graph is a visual representation of any function. Every point on the graph of the function f is represented by x, y. X being our input, y being our output. Okay? So, let's do an example. There are going to be multiple parts of this example. Okay? So, you don't have to redo the graph every time we do these parts. Okay? So, if I was given the function y equals x squared minus 4, and I was told to graph it, like if I didn't have this graph already, what I would do is I would come up with 5 points on the graph that I wanted to look at. Typically, you're always going to pick 0 and then 2 numbers on the outside. So we're just going to do 1, -1, and let's do 3 and -3. Sometimes you'll choose larger numbers depending on what the function is. You just want to be smart about it. So whenever I put in 0 into the function, so I have y equals, and then I'm going to put in 0, minus 4. So I'm going to evaluate, and I get 0 minus 4. And my output is going to be negative 4. So I put that in my table, negative 4. I'm going to go back and do all of these inputs, and I'm going to treat them the same way I did the 0. I'm going to substitute them in for x and see what I get out. Okay, so I went ahead and did all of the problems and filled in my table. I also wanted to go back and look at the function, the graph of the function. Notice how this right here, it stops, right? So I couldn't have gone outside of that. So I couldn't have gone up to 4. So that's why we stopped at 3. Now, the next one. So we have point B is negative 5, comma y, and it lies on F. Find the value of y. It says it lies on F. This just means the function. So this y equals x squared minus 4, okay? Now, it says that this is a point on the graph. It should be over here somewhere because negative 5 is here. So all we're going to do is we're going to plug in negative 5 and get out the value y. So y equals, and use your parentheses, negative 5 squared minus 4. Negative 5 squared is 25. And then 25 minus 4 is 21. So y equals 21. That is our output. That is the value of y. Okay? Moving on to C. What is the domain of f? Well, we see that it goes on over here, and then it comes down here, and it stops, right? So what are those values of x that I'm able to put in? Well, x goes all the way this way, and then it stops right here at x equals 3. So my domain is going to be x when it goes from, when it's less than, when x is less than or equal to 3. And we can say equal to because it is a closed hole. If it was an open hole, like this, then it would be not the equal to, just the less than symbol. Okay? So that is the domain of f. It's x when x is less than or equal to 3. Now let's look at the range. The range of f is all of the outputs. So you're looking at the y-axis, and you're seeing how far does your function go in the positive direction, and how low does it go in the negative direction. So as we can see, there's a point here, and it doesn't go before further than that, right? So what is the y value? The y value is negative 4, and the x value, of course, is 0. So the range is going to be y when y is greater than or equal to negative 4. And that is our range of f. We want to find the points where f intersects the x-axis and the y-axis. So we call these our x and y intercepts. The x-axis is this line right here, and the function crosses here and here. So these points are 2 comma 0, or negative 2 comma 0, and 2 comma 0. So the x-intercepts are at negative 2, 0, and 2, 0. Now the y-intercepts are when the function f crosses the y-axis, and that would be right here. And we've already labeled that in the last example as 0, negative 4. So the y-intercept is 0, comma negative 4. And that is it for that example. Now what I would like you to do is answer all 5 of those questions for the function y equals x plus 2, and use your table that you make to draw your graph. Okay? Make sure that you're using an x and y axis, you're using graph paper, and that you label your axes and your marks, so that way they're all in the same increments. Okay? Bring the example of the function and this example with you tomorrow, so that way we can use it for our class. Okay? Have a good evening.